Hello everyone and welcome to another Evil Equations video. Today I will be making another crazy equation involving some famous personalities. For this one I decided to use Bill Maher. Ah yes, Bill Maher has been a voice against stupidity for quite a while, and I have been enjoying his stuff since the old days. I particularly like his After Hours podcast, where he is perpetually trying to make some kind of cocktail while chatting with his guests. So I will be putting him into some weird mathematics in this episode. For my second individual, I chose Candace Owens. Now while I'm not as familiar with her as I am with Bill, I did see her recent video about the Mandela effect and decided, you know what, why not? I think a math video involving Bill Maher and Candace Owens should be a lot of fun, especially since Valentines is coming up, and I think the two of them would make a great couple. What do you guys think? Bill and Candace, smash or pass? Alright, anyways, let's get to the math. So I made this crazy thing. Feel free and pause the video to see if you can solve this monstrosity on your own. Now, it might seem like some ridiculous math, but the reality is that once you know a little bit of calculus, none of this stuff is particularly difficult. So let's do it. Let me show you how I built this evil equation. First of all, let's get back to the basics. We will start with Bill Maher. The idea is that in theory, everything and everyone can be expressed as some elaborate complicated mathematics. And while we don't know what this mathematics could be, we can confidently claim that Bill Maher should at least be equal to himself. And of course, the same applies to Candace Owens. As you can see, this now gives us two distinct equations. We will now use some simple division. It takes, for example, one full Candace to make a Candace. So we would get 1 if we divided Candace Owens by Candace Owens. The same goes for Bill. So we can see that in both cases, our result is 1, which means we can now combine the two of them. Amazing, isn't it? I love how math puts things together. I think Candace Owens and Bill Maher make a wonderful equation for this Valentine's Day. That's right, it is almost February the 14th when I'm making this video, so let's add some hearts to it. Wonderful, we can now move to some more complicated manipulations. Let's start with Candace. I wanted the denominator to look less obvious, so I thought I would use the natural log of e. Now, I don't want to go too deep into logarithms here, so all we need to know in this case is that the natural log of e is equal to 1. I can now use this in the bottom denominator. So Candace Owens multiplied by this log will still be Candace Owens. However, we now can use a special property of logs. We can make her into an exponent of e inside of this logarithm. Again, this is something you can do with logs. I just don't want my video to be too long trying to explain it. Okay, cool, we made the bottom of this division appear slightly distinct from the top. Keep in mind, all of this is still just equal to 1. Speaking of which, let's multiply it by another 1. We can now change this into something else. I myself am a big fan of this famous geometric series, which can be written as this infinite summation. All that we need to know is that it is equal to 1. So good, we can put it right here. We can now take Candace Owens and distribute her inside of this summation like so. And here we are, a funky looking expression. Perfect. Alright, let's now switch it up and go to Bill Maher. I want to get rid of this denominator, so we have only one picture of this guy's face. One way to do this is to give him the exponent of 0. Great, that is a good start. However, that 0 looks hideous. I need to hide it somehow. I want to make my math look like there could be some actual substance instead of this ugly nasty thing over here. One simple way I like to hide a 0 is by using trigonometry. In this case, I chose the sine of pi. Now this looks good, but anyone who knows a little bit about trig functions will see right through my shenanigans. No worries though, my next step is to do something with that innocent looking pi. I'm going to take it up a notch and hit that G-spot. I decided to use this crazy looking integral. Alright, so the function here, when graphed on the Cartesian plane, looks something like this. When we integrate, we are asking for the area underneath this line. And because both limits extend to infinity, our shape itself has the length of infinity. Now here's the crazy thing. Even though the length of this shape is infinite, the area is actually finite. And in this specific case, it is equal to pi. That's right, this integral equals pi. Great, so I now have this crazy looking exponent for Bill Maher. And you definitely need to know some decent math to figure out that this whole thing is simply some BS equal to 0. Now, at this point, This is fine, but I like to decorate my equations a little further just to give them that extra finesse. First of all, I'm not a big fan of this bracket, so I'll just get rid of it. For the next decoration, I chose to change this numerator into the exponent of -1. I think the function just looks neater this way. I also wanted to do something more with this -1, so I changed it into this thing. Of course, I still have this -1, which doesn't quite sit with me. I thought I might try changing it into one of those infinite nested roots. But to be honest, there's no real clean notation for these things. So I opted for a derivative instead. Now this derivative looked kinda chunky, so I figure I'll do something a little less conventional and use Newton's notation. That's right, this little dash here is just the derivative of x, which of course is equal to just 1. And here we are, a crazy way to make 0. What do you guys think? Does this look like a fun integral, or did I make something atrocious? Let me know in the comments. Okay, awesome. We have done some crazy mathematics on Maher, and we have Candace Owens waiting on the other side. And this equation already looks pretty intimidating. Alright, it is time to make our insane maneuver and put our lovebirds together. I am going to take this whole thing and put it over here, leaving just a simple number 1 behind. Now this works, but I'm not going to explain why. Again, brevity. See if you guys can figure it out on your own. Okay, so we have this crazy looking thing. And yes, I do like it. But I do think we can do a little bit more. I'm particularly not happy with this boring 2 over here. So I decided to use another integral. I know, 2 integrals and 1 equation. Pretty sick. For this one, I wanted to use a hyperbolic function, so I went with this thing. I then divided it by pi. Now this pi felt a little too naked down here, so I changed the division into a slash. I like this bit of shorthand sometimes. It can make the math look a little bit tidier. Then I set the top limit to infinity. This meant I would be calculating the area under this line, from 0 all the way to, again, infinity. The result would be 1/2. In order to change it into 2, I could multiply the whole thing by 4. However, instead, I decided to divide 1 by the whole thing. And again, to keep my math cleaner, I changed the numerator into the exponent of -1. Now we already have the n as the power, so we can simply make this into -n. And here it is, a crazy way to make the number 2. Alright everyone, we have created our insane equation, which is of course equal to 1. So here we are, a crazy looking math expression. Maher and Candace Owens tangled together into one equation using some lovely mathematics. What do you think? Do Candace and Bill have good algebra between them? Can they really become one? Or is my math really evil and I'm trying to combine oil with water? I hope you guys have a wonderful time this Valentine's Day. Thank you for watching this crazy video. Check out my other stuff. If you like it, you know what to do. Have a wonderful day and I'll see you all in the next one.